Welcome to Midnight Hell. I am your host, Midnight. Here we explore the intriguing mysteries of space, uncovering the unknown, and journeying to the farthest reaches of the cosmos. Today, we will be diving into a fascinating topic, the shrinking moon. Did you know our moon is shrinking? Yes, it is. Now, before you rush to your window to check, let's clarify that it's not something you can see with naked eyes. The changes are subtle, yet significant, and they've been happening for billions of years. This fascinating discovery was made by NASA, the folks who keep a watchful eye on the cosmos for us. So what's causing the moon to shrink? It's a process similar to what happens when you leave a grape out in the sun, and it shrinks into a raisin. In the case of the moon, it's not the sun, but its own interior that's cooling down. This cooling causes the moon to contract, which, in turn, causes its surface crust to break and form what are called thrust faults. Picture this. You're holding a round balloon and you let some air out. What happens? The surface of the balloon gets wrinkled. That's pretty much what's happening to our moon. As it shrinks, its crust, which is brittle, breaks and forms cliffs or faults. These faults can be dozens of miles long and several miles high. Now here's where things get even more interesting. These faults aren't just static features of the lunar landscape. They are active and evolving. As the moon continues to cool and shrink, the faults slip and slide, causing moonquakes. These moonquakes are not your average earthquakes. They occur much deeper in the moon's interior and can be quite powerful. Some recorded by Apollo missions were of magnitude 5 on the Richter scale, which would be considered moderate if they occurred here on Earth. So there you have it. Our moon, the serene guardian of our night sky, is not as static as it seems. It's shrinking, cracking and quaking, constantly changing and evolving in response to the forces within it. These faults are not just there for show, they are active in producing moonquakes today. Moonquakes, similar to earthquakes, are happening on the moon. Yes, you heard that right. Our silvery celestial neighbor isn't as still as it appears. But how do we know this? Well, during the famed Apollo missions, astronauts placed seismometers on the moon's surface. These intricate devices, much like their Earth counterparts, were designed to detect and record seismic activity. And they did. From 1969 to 1977, these lunar seismometers recorded 28 shallow moonquakes. Now, you might be wondering, how can we be sure these were actual moonquakes and not just cosmic noise? This is where the power of modern technology comes in. Researchers developed a new algorithm, a sophisticated set of rules for calculations, to analyze the data collected from these seismometers. And guess what? They found that 8 of these recorded quakes occurred near visible faults on the moon's surface, suggesting that these were not random but likely caused by fault slip events. But the story doesn't end there. The Lunar Reconnaissance Orbiter, a NASA spacecraft orbiting the moon, has been sending back detailed images of the lunar surface. These images have provided additional evidence of recent moonquake activity, showing visible shifts and changes on the moon's crust over time. So, what does all this mean? These moonquakes are not only a fascinating phenomenon in themselves, but they also offer us a unique glimpse into the moon's interior processes. They help us understand how the moon's surface is changing, how it's shrinking, and how this could possibly be similar to processes happening on other celestial bodies. These moonquakes provide an insight into the moon's interior processes. The moon's shrinkage is not a unique phenomenon in our solar system. In fact, our celestial neighbor Mercury also experiences a similar phenomenon. While the moon and Mercury are two distinct celestial bodies with their own unique compositions and characteristics, they both share the commonality of shrinkage due to cooling of their interiors. This cooling process leads to the breaking and formation of thrust faults on their surfaces. Imagine it as your skin wrinkling as you age, only on a planetary scale. However, the degree of this shrinkage varies between these two celestial bodies. Mercury, being closer to the Sun, has undergone a greater degree of shrinkage, resulting in larger thrust faults on its surface as compared to the moon. But why does this matter? Why should we care about the shrinkage of the moon or Mercury? Well, these processes provide valuable insights into the geological activity and evolution of these celestial bodies. The size and number of thrust faults and the moonquakes or Mercury quakes they cause can tell us a lot about what's happening beneath their surfaces. Moreover, these observations aren't just about satisfying our curiosity. They have practical implications too. For instance, if we are to establish sustainable missions on the moon, as NASA plans to, Understanding these geological processes will be crucial. The same goes for any potential future missions to Mercury. So while the Moon and Mercury may be far from us, their shrinkage and the resulting geological activity are not just distant phenomena. They are part of the broader narrative of understanding our place in the cosmos, of unraveling the mysteries of our solar system. The study of these shrinkages helps us understand more about our solar system. NASA is not done with the Moon yet. In fact, the space agency has ambitious plans to revisit our celestial neighbor. Picture this. By the year 2024, NASA aims to send astronauts back to the Moon. But this isn't a one-off trip, oh no. The long-term vision is to establish sustainable missions by 2028. Why, you might ask? Well, these missions could provide invaluable insights into the Moon's intriguing shrinkage and the mysterious moonquakes. It's like solving a cosmic detective story. The astronauts will not only walk on the lunar surface, but they will also conduct experiments and gather data. And who knows, they might even set up permanent research stations. The possibility of sustainable missions is truly exciting. It means staying on the Moon for longer durations, conducting more research, and gathering more data. This could help scientists understand more about the Moon's interior processes and its geological activity. Imagine the wealth of knowledge that can be gained from these missions. It could revolutionize our understanding of the Moon, and by extension, other celestial bodies. We could learn more about the Moon's past, its present, and even its future. So, as we look towards the future, we can anticipate thrilling discoveries and advancements. The Moon has held our fascination for centuries, and it continues to do so. With these upcoming missions, we are on the brink of uncovering secrets that have been hidden in the lunar crust for billions of years. These missions could reveal even more fascinating facts about our Moon. The Moon has been our silent companion for ages, but it still holds many secrets. As we've journeyed through today's exploration, we've uncovered some fascinating truths about our closest celestial neighbor. The Moon, despite its familiar face, continues to surprise us with its dynamic nature. It's not just a static, lifeless rock orbiting our planet. It's shrinking, its surface crust breaking to form thrust faults, echoing a distant cosmic rhythm in the form of moonquakes. We've also discovered that these phenomena aren't unique to the Moon. Mercury, another celestial body in our solar system, experiences similar shrinkage, albeit at a larger scale, with larger thrust faults as evidence. These revelations underscore the importance of continued space exploration. It's not merely about reaching further into the cosmos, but also about revisiting and understanding the worlds we think we know. Each discovery, each mission, like NASA's planned return to the Moon, adds another piece to the grand puzzle of the universe. So, as we gaze up at the night sky, let's remember that every star, every planet, every moon, including our own, holds a story that's waiting to be told, waiting to be discovered. What are your thoughts on this? Share them in the comments below. Don't forget to subscribe to Midnight Hell for more fascinating space content. Midnight out.